So let's get into adding vectors. Now, what I'd like to do when I'm adding vectors is I'm actually just going to be thinking of this as a displacement. So let's actually take this object here and displace it a certain amount. So vector 1, let's call this vector n. And that's the notation that we're going to be using to identify these vectors. And so once again, remember that a vector has both a magnitude and a direction. So the direction is going to be to the north of this magnitude. And vector 2, let's call it east. Vector e for east. And it's going to, once again, also have a magnitude of this amount and in the direction to the east. Okay, so those are our two vectors. And what we're going to do here is perform a little vector addition. So let's take vector n and add that to vector e. And the result here will be our resultant vector. Let's call that R1. So this is our resultant vector. So I just want to cover a little terminology right now. Let's look at these two. So these two vectors are what's referred to as component vectors, and this is our resultant vector. So if I actually open up my wallet and I'm looking at all the contents in my wallet, I have some credit cards, a very little amount of cash in there. I have my IDs, and those are the components of my wallet. So when I'm looking at these vectors over here, these are the two component vectors, and we'll see that actually the result is a resultant vector. So what I'm going to do here is I'm going to take, so the first instruction, once again, I'm going to be displacing this object. And the first instruction that's being given is to go vector n. So let's do that. Let's actually have our dot over here. And the very first instruction is to go vector n. So I have my vector n right here. And the way that I like to think about this is I'm just going to take this object, and let's say it's starting over here, and the instruction tells us to move it vector n. So now it's over here. Okay, so now what's next? Oh, it says, hey, the next instruction is to go vector e. So now the dot is over here, and let's go vector e. So if we're displacing our dot, what do? We're going to bring it from here to over here. I like to look at these as if they're instructions. Okay, so, well, what's the result? Hey, you know what? The dot went from here to over here. And that's the end, right? Well, the result is it went from here and it ended up over here. This is our result. This is our resultant vector. Okay, so let's do another problem. Let's do another example. All right, so let's change this up a little bit. It's not that much of a change, but nevertheless so. We're just going to say vector e plus vector n is equal to resultant vector number 2. Okay, so, well, once again, if we're going to be looking at these like they're instructions, let's move our dot around. So the very first instruction tells us, let's move our object e, vector e. So we're just going to be moving it that much over there, and that's vector e. So we're basically saying that we're going to be moving our dot from here to here. Okay, and then what's our next instruction? Well, the very next thing that we do is move it n. So vector n is just going up like this. So we're just going to be taking our dot and moving up vector n. So it started down here and it ended up over here. So our dot traveled from here to here and then here to here, and the result, what you could say, is that it went from here all the way to over here. And this is our resultant vector number 2. And what we should be basically seeing here is, maybe I didn't do this perfectly, but the idea is, hey, you know what? Isn't moving this north and then east, this pretty much going to be resulting in the same thing as east then north? Yeah, you know what? It pretty much is. So what we should basically see here is if I was to move this over here like this, we should see that the answers are pretty much the same, which if I drew this out perfectly, it would be, but I think that you just have to accept the idea that I didn't draw this out perfectly, and that's just kind of the way it is. So that's simply adding vectors.